Welcome to Nayagnia Substation, NY82, located in Nayagnia, Navrongo District in the Upper East region of Ghana. The station was commissioned in 2018 and comprises two substations of different voltages. One end is 330 kV to 225 kV, solely for the supply of power to Sonabel in Burkina Faso, and the other end is 330 kV to 161 kV, which interconnects into the 161 kV network of GRIDCo.
What you see here is a replacement of a 200 MVA transformer. The transformer has a permanent damage internally.
The damaged transformer has to be transported back to China.
We're going to load them, we're going to check them up, skid them, bring them up, and then we're going to load them on our 14 axle gold over trailer. And then we will transport them approx 5 days back to Tema port, and then it will go directly in the ship.
In order to ensure reliability and continuity of power supply to Burkina Faso, it became apparent that a transformer with the same capacity, which is 200 MVA, is looked for and installed in its position while the faulted transformer is being worked on in China. Management was able to locate a transformer which has been installed at Elubu in Western region, decommissioned and transported from Elubu to Nayagnia Substation.
The defective transformer was 200 MVA 330 kV / 225 kV / 34.5 kV step-down auto transformer. The customer, Sonabel in Burkina Faso, needs a transmission voltage of 225 kV. The new transformer installed is 200 MVA 225 kV to 161 to 11.5 kV step-down transformer. We will now use one of the 330 kV to 161 kV sino-hydro transformers, the one that interconnects into the 161 kV network of GRIDCo. To assist us with the conversion, a jumper is used as bypass to link the 161 kV bus bar voltage to the 330 kV bus bar voltage. The 330 kV circuit breakers of the sino-hydro transformer will now be energized at 161 kV voltage after the bypass. The circuit breaker is closed and the bus bar's 330 kV becomes 161 kV. The converted bus bar now becomes the input of the new 161 kV / 225 kV single-phase auto transformers. This is to provide hot standby supply of electricity to Sonabel in Burkina Faso.
So what you see here is work going on the transformer which was brought from Elubu to be installed. All the accessories are in place, installed in position, and what is currently going on is treatment of the oil.
This is a transformer currently under treatment, which we are draining oil from the transformer into the plant. Our main job here, as far as this project is concerned, is to treat the transformer oil. When we finish, we conduct tests, bringing the transformer from a far distance together with the oil. There's a need for us to make sure that the oil is within acceptable level as far as our moisture is concerned. Basically what we are doing is that we are taking the transformer oil from the transformer, heating it up to certain temperature level. Water basically boils at 100 degrees, while the transformer oil, when we heat it almost up to 60 to 70, is equivalent to our water boiling at 100 degrees. And therefore, as a result of that, the moisture in the oil is completely vaporized. This is so crucial because any moisture that is entering into the transformer has capacity to increase the transformer temperature. And number one enemy of a transformer is basically its temperature rise.
Each transformer has two thermometers, one for monitoring the temperature of the winding and one for monitoring the temperature of the oil. The transformer by transformation is made out of windings, and the windings are made out of copper. The copper has a resistance. So anytime you push current through the copper, meaning the customer connected to the 225 section is drawing up load, current will automatically flow. And by the resistance, you create heat. So you want to regulate the heat.
This machine is what we call Pruce 650. We use it to calibrate the temperature sensing devices. So the standard that is set here now is 60. It's supposed to ram it up to 60. Whilst it's going, you also be reading down there from the main meter.
We use it to also sound an alarm to the operator for him to know that the level of temperature that the transformer is running is becoming dangerously high.
I'm the operator here, and basically as an operator, your responsibilities are to check the performance of the equipment by taking readings. Every control room will have a control panels, and these control panels has relays there. We have meters there, and these meters, some of them are energy meters, monitoring the amount of load that goes out and the amount of load that also comes in.
When the temperature rises up to 70, then the fans which are under these radiators will come on. The group 1 will come on to cool it.
The transformer's cooling depends on the type of load. Between 0 and 25 MVA, you are using the oil natural, air natural. The oil is the one that is cooling the windings of the transformer up to 25 MVA. Now, if you move beyond 25 MVA, the fans will come on automatically. So beyond that 25 MVA, then that one you have now moved from oil natural, air forced. So the fans come on and then forces the cooling. But the one we have here is 3. Now, for you to get to the full load, which is the 200/3, that one is oil forced, air forced. What it means is that the owner is there, the fan, you are forcing the cooling, and then there's also a pump, which is also forcing the oil to do the cooling. So you have 3. So you have oil forced, air forced. That is the type of cooling system that we have here.
The installed transformer, which is now permanently faulted, was a 330 kV to 225 kV voltage. However, the new one, which was brought from Elubu, is not same, but rather 161 kV to 225.
We needed to convert these two buses, one of them to 161 kV, so that we can be able to power the transformer that we are installing. And we will be dropping the 330 and hook it onto the 161 so that this bus will be energized for 161. The arrangement here was initially for 330, so we needed to change some parameters there so that it will conform with the new transformer that we have brought on board, which is 161 input, and then the output will be 225. So we needed to change the lightning arrestor that protect the input of the transformer. When there is a lightning stroke, it induces a higher voltage into the system, and we don't want our transformer to get damaged. So there is a need to protect the input of the transformer with the lightning arrestor. What the line people are trying to do now is to do the final termination of the transformer input, which is the 161. Then we will drop all the leads so that the PNC and electrical will do their tests.
What we are doing now is wiring by protection and control section. And the work going on in that panel there is integration of the old wiring of the faulted transformer to provide protection for the new transformers that have been installed. The existing faulted transformer was a step-down transformer from 330 to 225. The new one is going to be a step-up transformer from 161 kV to 225 kV.
Ghana Grid Company Limited, the backbone to power delivery.